Hey guys, it's Miss Ava and I'm here with Calculina, and in this lesson we are going to go over how to factor quadratic trinomials. And this is a topic that a lot of students struggle with, even students who are older and in advanced classes. Sometimes they'll still be uncertain about their factoring. And as we go through, you're going to see why that happens in this lesson. But if you're a student that struggles with that, whether this is just something new that you've learned or it's something that you learned years ago, but it still kind of haunts you right now, in this lesson, we're going to clear all of that up for you. So let's get started. So to start with, quadratic trinomials are polynomial algebraic expressions that are in the format of x squared plus bx plus c. Here, the x is representing a variable. So this is the variable in this expression. And the a, b, and c are numbers that are specific to each problem. And so what that means, we're going to look at some of these. What are the coefficients or the constants in each of the following? So that's another way of thinking about these. These are also called coefficients for the a and the b, and then the c is called a constant right there. So a and b are coefficients of the x and the x squared, and then the c is the constant. So in these problems that we can see right here, what would the a, b, and c be for this problem, Calculina? What do you think?
Um, I'm not sure.
Well, all you have to look for is like what number is in the same position as this one over here in this expression.
Oh, okay. Is it the 8 or the 2?
Yes, that is correct. So the 2 is the A over here. What about the B? Which one would be the B?
Um, that would be the 5.
Good. And then the C here?
That would be a 10.
Close. It's actually a negative 10. So you just put a negative here.
Oh, okay. But how come, well, this one says plus and this is minus. So how do you know which one to go with?
Well, what this is really saying is like you can rewrite this one as if it was a plus a negative 10, like this. And then it's kind of easier to see that the C right here would just be the negative 10. Yeah?
Oh, okay. Yeah.
Okay, cool. And then that's also the case for these other ones. So like B here, if this had been a negative 5, then your B would have been a negative 5, and so on. Okay, I'm just going to color code the rest of these as well. So that's A. Okay, and then now tell me for the next one. What do you think here? What's the A, B, and C in this problem?
Okay. So the A is the negative 3.
Oh, okay. So actually, this one is not the negative 3. See, the A is like the coefficient for x squared. It's not the coefficient for the x. So those are two different terms, and you have to actually be particular about that. Like you have to look at the right one. So here, the x squared is this guy, and the x is just this one. So what's the A here?
Oh, okay. So that would be the 7.
Yes, awesome. And then the B?
That's negative 3.
Good. And then what would the C be?
Do you just write a 0?
Yes, the C in this case is 0, the constant. All right, good. And then let's try number 3 as well. So in this case, what's the A?
0?
Nope. So when you don't see like a number in front with the x squared, then it implies that there's a 1 in front.
Oh, okay. So that would just be 1.
Yes. And then the B?
That would be a negative 1.
Awesome. And last one, C.
That is just going to be 11.
Perfect. Okay, so the next thing I want to talk about is how to tell if a polynomial is a quadratic and how to tell if it's a trinomial. So a polynomial is quadratic if the highest degree of the variable is a 2. So let me write that down. The highest degree of the variable is 2. Oh, I'm going to run out of space. I'll just write it like this, equals 2. Okay, so that's how you know that it is a quadratic. And then a polynomial is trinomial if it has 3 terms that are separated by adding and subtracting. So if it has 3 terms separated by addition or subtraction. So you can see like all of these right here, these are 3 terms and they're separated with addition and subtraction signs. So that is a trinomial. And then when it talks about the highest degree, well, let's just look at these examples and then hopefully you'll see what I mean. So in this first problem, what do you think? Is this a quadratic trinomial?
Um, how do you know?
Well, so for the quadratic part, we have to look at the degree. And what that means is that you're going to go to the x or to the variable and you're going to look at what is the highest degree, what's the highest exponent. In this case, it is a 2. And so, yes, this is a quadratic. Is it a trinomial, though?
No.
Exactly. This is not a quadratic trinomial because it doesn't have the 3 parts. It doesn't have A, B, and C. Which ones does it have, by the way? Like out of the ax squared plus bx plus c, which of these does this one have?
Um, it has the A and it has a C.
Perfect. Yes. This is called a quadratic binomial because there's only 2 parts. Okay, how about number 2? What do you think there?
Um, that one it is a quadratic?
Yes, that's correct because the highest degree is 2. And then what about, is it a trinomial?
No.
Exactly. This one is also a quadratic binomial. And which terms does it have here out of the A, B, and C?
This one has an A and a B.
Perfect, exactly. All right, so then number 3, what do you think here?
This one, yes, it is a quadratic trinomial.
Well, actually, see, what's the highest degree in this problem? What do you think?
Oh, okay, it's a 3.
Yes, so that is why this is not a quadratic trinomial. Is it a trinomial?
Yes.
It is good. Okay, but this is going to be a cubic trinomial. So this one is cubic trinomial. And that's because of the 3. And then how about number 4?
That one, so that's not going to be a quadratic trinomial?
Exactly. Because the highest degree here is what?
The 4?
Yes, this is called a quartic trinomial. But the thing is, this one, we can actually put it into the format of a quadratic trinomial. So let me just show you that on the side. So it's 5x to the fourth plus 2x squared minus 7 right now. And then if we want to put it into a quadratic form, right, the main thing is that the ratio for the exponents, it has to be like something to the second power, then the next one has to be to the first power, and then the last one has to be to the 0 power. Although anything to the 0 power is just 1, and so that's why we don't even have the x over here, because it just turns into a 1. But that doesn't mean that this isn't what's happening. So it has to have that same ratio over here. And does this one have the 2 to 1 to 0 ratio?
Uh, yes.
Good, it does. So 4 to 2 to 0 is the same thing as the 2 to 1 to 0 ratio. So that means the way that I could do this, I mean, just to kind of give you an idea, you don't have to actually go through this step, but just to give you an idea of what we're doing, you could use like a new variable. You could introduce a variable like y equals x squared. So you'd use the one in the middle here. And then now if we replace all the x squares with a y in here, then we will basically have a quadratic trinomial that we can factor in the same way. So let me show you that would be like 5, and then this x to the fourth right here would turn into a y squared, yeah?
Yeah.
And then this 2x squared would then turn into 2y, and then this last part minus 7 would just be the minus 7. And then now, is this a quadratic trinomial?
Yes.
Okay, good. So that's how you could do that. As long as you have that same ratio of 2 to 1 to 0 with the degrees, then you can put it into a quadratic format and you can factor it as if it is a quadratic trinomial. So you could use the same method that we're going to do in this lesson. Then the next thing, when it comes to factoring quadratic trinomials, is what it means to factor a quadratic trinomial. That means that we're taking it from this form right here, the ax squared plus bx plus c, which by the way is called standard form, and we're putting it into this new format right here, which it looks like two like groups that are multiplied together, and this is called intercept form. Okay, so in intercept form, you can see that these are actually going to end up being binomials. Intercept form is a product of two binomials, whereas the standard form is just the regular trinomial. Okay, and then now before we really get into how to factor quadratic trinomials, just a couple more points I want to state here. First thing is that not all quadratic trinomials can be factored, and you're going to see some examples of ones that can't. And then the other point is that factoring is about learning the process. That's really all it is. It's just like a step-by-step process, and you just need to learn or memorize that process, which means you really just need to practice it until you are not getting these wrong. And once you're at that point, then you have this process down pat pretty much. Okay, so now let's get into this process. We're going to start with this example right here. Factor the following. So this is a quadratic trinomial, yes?
Yeah.
Okay, so the first thing you have to do when you are trying to factor a quadratic trinomial is you have to look for two numbers such that when you multiply them, you get something. I'm going to tell you what that is in a second. And then when you add them together, you get something else. And the blank over here, this first blank is going to be a times c. So over here, what's the a and what's the c?
Um, so that's the 5 and the -7.
Exactly. So the 5 and the -7, we multiply them, and what do we get?
That's going to be -35.
Okay, good. So we write -35 over here. And then the other one, the 2 that they have to add up to, is going to be this guy right in the middle. So that's a 2. So the b value is for the adding and subtracting, and a times c is what you use for the multiplying. And then now looking at these two numbers, basically this number, whatever this is, has to be exactly the same as for the adding, and then this one has to be the same over here. So you're looking for two numbers that will multiply to give us this -35, and when you add them together, you get a +2. So what can you think of?
Um, it could be anything, couldn't it?
Well, I mean, maybe if you're just looking at the two, because then, yeah, you can come up with a lot of different options. You could say 5 minus 3, and then that's a 2. But like, I would look at the multiplication ones first, because that really narrows it down what your options might be. So why don't you tell me some numbers that multiply to give me the -35?
Okay, so that would be like 5 times 7.
Yes, 5 times 7 will give you the 35. But then is there any way to add a 5 and 7 together and get +2?
Yes.
Okay, good. What would that be?
Um, I'm not sure.
Okay, let me try explaining that again. So we have these two numbers, the 5 and the 7. When we multiply them, it has to give us a -35. And then when we add whatever those two numbers are, it has to give us a +2. So maybe the arrangement that would work here is, let's say if we use a 7 and a -5, right? Isn't that going to give us a positive 2?
Yes.
And then what about when we multiply 7 times negative 5? Does that work out for the negative 35?
Yes.
Okay, so that's what you have to do. You have to find those two numbers that are going to multiply to give you the negative 35 and add up to give you 2. This is the hard part right here. Once you have this, the next part is like an automated process, and all you have to do is just follow the steps. So the steps are this. The first thing you're going to do is write these two down and kind of leave space in between. So it's going to be 5x squared and then the minus 7 over here all the way on the side. And then in between over here, instead of the 2x right here, you're going to use the 7 and the negative 5 that we came up with right here. So you're going to put the 7, it's going to be plus 7x minus 5x. So you have to still use that x right here. You have to keep bringing that along, but the numbers are coming from right here. Is that cool?
Okay.
And then once you have it written like this, you see there's 4 terms. You do factor by grouping at this point. So if you don't know how to do that, I have another video on that coming out soon. So check in the description. The link might be there by now, depending on when you're watching this. But I'm going to go through that process really quick right now as well, just not in as much detail. So basically, you put the first group together right there, and then this is going to be a second group right here. And then out of the first group, you have to factor out GCF. So what is the GCF over here?
Um, uh, is it like just X?
Yes, that is correct. And by the way, guys, I have a video on the GCF and LCM as well. And that one I'm definitely going to leave a link for in the description as well. So be sure to check that out because if you're not sure what we're talking about here, you might want to go visit that one first. But yes, the GCF is just going to be the x here. And then what's going to be left in the parentheses. So what I mean by that is you have to divide each one of these terms by the GCF and then write the answer down right here.
Oh, okay. Would that just be like a 5?
Close. Let's try it on the side over here. So if I did 5x squared divided by x, right, then this x will cancel with one of these x's right here, and you just have a regular x left. So this would just be 5x, yeah?
Oh, okay. Yes.
So that's what you write down, the 5x. And then you do the same thing for the 7x divided by x. What will that give you?
So that is just going to be like a 7?
Perfect. So plus 7, we close up that parentheses, and then we are now going to do the same thing for the next group here. So what might be the GCF of the second group?
Uh, there isn't one.
Well, there is. I mean, when there's nothing, remember we just use a 1, yeah?
Oh, okay.
Yes, but we also need a sign with this one. So what I would like you to do is take the sign of whatever number is here, whatever sign is going with that one, that's the sign we're going to use. So we'll just put a negative right here. And then now that is the GCF, and that's what we have to divide each one of these terms by. So what is negative 5x divided by negative 1?
That's just going to be positive 5x.
Perfect. And then now if we do negative 7 divided by negative 1?
That's going to be plus 7.
Awesome. Okay, and then once you have this, then you're pretty much almost there. The last final step here is that you want to write it like 5x plus 7, and then the other parentheses is going to be x minus 1. So let me show you where all of that came from. The 5x plus 7 is these guys. And you see how they're both the same?
Yeah.
So that is what's supposed to happen when you do this correctly. Both of your factors are supposed to be the same over here. And those kind of turn into like the GCF. So it's like you're taking these out from the whole thing this time. And so if we take that out as a GCF, then that's what goes in the front. And then what is left over for the other parentheses is going to be this x that comes from here, or the number that's in front there. and then the negative 1 from here. So that's where everything came from. And that is the process, my friends. That's all you got to do, and then you are all factored. Okay, so we're going to do the same thing again with another problem. Okay, this one, so the first step again is to find two numbers that are going to multiply to give us something and add up to give us something else. So what are those blank spaces? What do you think, Calculina?
Okay, so you said that it was A times C for the first one, right?
Yes,
Okay, so the A is the 6 and the C is the 1. So that's just going to be a 6.
perfect. This one's a 6. And then for adding and subtracting, what number should that be?
So that is like the B.
Exactly. And what is that in this case?
The B is like the -5.
That is correct. Okay, so then we just need to find two numbers that can multiply to give us positive 6 and will add up to give us -5. What do you think?
Uh, you could do like 6 times 1 will give you 6.
Yes, so if I did 6 times 1, right, then how would I get the -5 with a 6 and a 1?
You would have to have the -6 and a +1.
Oh, I see. So if I put -6, +1 right here, that works out for sure. What about up here? Is that going to work out?
Uh, oh, no.
Yeah, exactly, because this is going to give you a -6 when you multiply here, right? Okay, so that means that these factors are not the ones. So that's kind of why I chose this problem, because I wanted you guys to see that just because you find two factors that seem like they might work, it doesn't mean that, you want to make sure that it works with the signs. So can we think of any two other numbers that when you multiply, you get 6, and then that we could possibly work with?
Well, 2 and 3.
Yes, 2 times 3. And then how could we add or subtract a 2 and a 3 so that we get -5?
Um, like they would both have to be negative.
Yes, you'd have to have -2 and a -3 right here. And then that will give you a -5 when you add them. And then does it work out over here as well?
Yes, that gives you a +6, right?
Yes, it does. Okay, so then what was next? Here, I'm going to let you look up here and see what we did. So do you see how next thing we after we had this part filled in, then we went back to the problem and we rewrote the first part and the second part separately, and then in between we used the 7 and the -5. So then tell me what to do here.
Okay, so then you're going to write 6x squared
Yes,
and leave some space in between, and then you just write the +1 at the end.
awesome. And then what am I writing in between here?
You're going to write -2 minus 3.
Yes, kind of. You can't forget about the x's, so you need to put the x's in there. So it's going to be -2x and then minus 3x like this. And then now what's next?
Uh,
Here, you want to look at this problem? You see what we did here? We grouped them, yeah?
oh, okay, yes.
And then what did we do after we grouped them?
We took out the GCF.
Yes, we took out the GCF from each one of those two groups. Okay, so let's try that over here. So first group is right here. This is the second group. And then what is the GCF of this first group?
That's gonna be a 2
Yes,
and an X.
perfect. So 2x, and then what is going to be in the parentheses then?
Um, hmm. How do we do that again?
Well, you just have to divide this one divided by this. And what will that be? So what's 6x squared divided by 2x?
Um, would that be, that's just going to be like a 3x?
Perfect. So 3x. And then what are you going to get if you divide the negative 2x by 2x?
Um, that would be like a negative
Yes, exactly. So that's a negative 1. And then how about over here? What's the GCF?
1. Well, there's nothing, so then you can just use a 1.
Yes. And then what sign goes with that 1?
Um, I'm not sure.
Okay, so remember you just use the sign that's right in the middle here. That's the sign that you're going to copy over, yeah?
Oh, okay. So, just the negative.
Yes. And then what's going to be in the parentheses this time?
Um, so I'm doing the negative 3x divided by the negative 1. So that's just going to be positive 3x.
Yes.
And then it's like the positive 1 divided by negative 1. So that's just the negative 1.
Perfect. Okay, and then we can check here. Does this match with this one?
Yes.
Awesome. Then we are good to go. And now we can put it into the factored form. So go for it. What's that going to be?
So you'll have a 3x minus 1. And then the other one is going to be like 2x minus 1.
Perfect. This is it. Yes. And one thing I want to say is that you don't have to put them in this order. You can write the 2x minus 1 first if you want, and then write this one. It doesn't really matter. But yes, that's kind of how that's done. So now hopefully you guys are starting to see the process of how to do this. Here's the next problem. Okay, so what was the first step?
You have to find two numbers that multiply to give you something and then add up to give you something.
Yes, awesome. And what will be those somethings? Tell me what to put in these blanks.
Okay, so the first one is going to be a 4 times a 90, which is 360.
Yes, but remember this is a negative 90, so you have to use, it's really 4 times negative 90, yeah? So what is that?
Oh, okay, so it's negative 360.
Yes, that's correct. Very nice. And then what's in the next blank?
So that's just going to be the negative 9.
Perfect. Okay. So the thing I wanted to show you with this example is like, see how this number is really big? So I want to show you how to handle problems where the A times C ends up being kind of big, and you have a lot of choices when it comes to the different set of numbers that you have to go through to find your negative 9. So you can definitely go through all the factors and everything, but the other suggestion that I have for how to do these problems, okay, what you're going to do is you're going to use this 360 and make factor trees. So let's do that on the side really quick over here. So 360, and you just make a factor tree for that one. Okay, perfect. So then now we have a 2 times 2 times 2 times 3 times 3 times 5. Yeah?
Yes,
Okay, so we take those factors. Let me write them over here. We have a 2 times 2 times 2 times 3 times 3 times 5. Yeah?
yes,
Okay, so what you're going to do is you're going to create these two boxes like this, and all of the numbers have to go into a box. And you can put all of the numbers into the same box and put a 1 in the other. But other than that, you can also just split them up. So for example, I could try like putting two of the 2's in here, and then I could put a 3 in here, and then I could also do the other 2 over here, put the other 3 in here, and then the 5 over here, and then what will we get? Like what are each of these numbers when you multiply them out? What's this going to be?
So that would be 2 times 2, which is 4, and then times 3 is 12.
Awesome. And then the next one?
This one is going to be 6 times 5, so 30.
Yes. And so these are two options, two factors that we're looking at. Is there any way to add or subtract a 12 and a 30 to get a negative 9?
No.
Exactly. So then we are going to have to try different factors over here. So I could, let's say if I want to take out this 5 over here and put it over here in the other box, then we could try that one out. So it's like, it's just a way of kind of looking at this in a systematic way that hopefully kind of helps. But also there's sometimes clues that you can use. Like for example, right here, we know that the answer that we want is negative 9 when we add and subtract those numbers. So if you think about negative 9, like how can you add two numbers and get a 9 or like an odd number? If we add two even numbers, are we going to get an odd number?
No, that's even, right?
Yes, so that does not give us an odd number. And then what about adding odd plus odd? Could that work?
Uh, no.
Exactly. Like you can think of 3 plus 3, and that's a 6. So obviously that does not work. That gives you an even. So that means that we need an even plus an odd number in order to get an odd number, right?
Yes.
So what that tells us is that over here, all of the 2's are going to have to go in one box. We can't separate them because that's the way that we're going to keep one of them even. And then, we can use the odd numbers in one box or the other and see what works. So if I put a 2 times 2 times 2 in here, and then now we just have to look at the 3 times 3 times 5. So we could do, let's say if we put one of the 3's over here and we put the 3 times 5 over here, what do we end up with?
Well, the second one's going to be 15.
Awesome. How about this one?
That would be, so 2 times 2 is 4, times 2 is 8, and then 8 times 3, that's 24, right?
Yes, it is 24. All right. How about this? Does this work? Can we use a 24 and a 15 to get the negative 9?
Oh, yeah, we can.
Good. What will the numbers have to be in these boxes? What's going to give us that negative 9?
Uh, like if you use a negative 24 and a positive 15.
Perfect. Yes. Negative 24, positive 15. That's how we're going to get this negative 9. And these two will also just multiply and give us the negative 360. So it works. Okay, so like I said, this part is usually the harder part, figuring out what those numbers are. Once you have that, it kind of turns into pretty simple process, pretty easy to follow. Okay, so what we'll do is we're just going to set this up and then we're going to move on. We're not actually going to finish this one. You guys can try it at home and we will leave this for you. And then we also have the answers in the answered key. Okay, so just to set it up, what do I do?
Okay, you're going to write the 4x squared,
Uh-huh.
and then you copy down the negative 90 on the side.
Okay.
And then in the middle, you will write minus 24, and then minus 24x, and then plus 15x.
Perfect. And then here, what would be the next few steps?
Then you would just group them, and then you would take out the GCF from each of the groups.
Yes, exactly. Okay, so we are going to leave the rest of this for you guys to do, and then let's look at the next one. So here, what's the first step?
Okay, so two numbers that multiply to give you something, and then add up to give you something.
Yes, and can you tell me what those are?
Um, the bottom one is going to be the negative 15.
Awesome. Negative 15 right here. And then what about when you're multiplying?
So you just do the 9 times 25.
Yes.
Uh,
Think about quarters. How many cents would you have if you had 9 quarters?
oh, so that would be 225.
Perfect. So 225. That's the situation that we have here. We need two numbers that multiply to give us 225 and add up to give us negative 15. All right, so maybe what we should do is try this on the side with the factor tree again. Yeah?
Yeah.
Okay, cool. So let's break down that 225. Awesome. So we get 3 times 3 times 5 times 5. Okay, so let's go back here and try making those boxes again. 3 times 3 times 5 times 5. And here are the two boxes. And let's see, if we try putting those numbers in here, is there a way to get negative 15?
Um, we could do the 3 times 5, and then in the other one you could just do the 5.
Okay, and then what will this give you?
Um, 3 times 3 is 9 times 5, that's going to be 45.
Yes, 45 and 5. Is that going to work for the negative 15?
Uh, no.
Okay, so what else would you like to try?
Okay, well, what if we, um, put one of the 3's in the other one?
Okay, so you want me to put one of the threes over here. If I put one 3 over here, then each box has a 3 and a 5, and so what will both of them be?
That's just going to be like 15 and 15.
Yes, and is there a way to use 15 and 15 in order to get a negative 15 by adding or subtracting?
No.
Okay, awesome. And what's the only other one that we haven't tried yet?
Um, like putting the 5's together in one and then and with one 3.
Okay, cool. Let's try that one really quick. But what do you think? Is that one going to work?
Uh, Probably not.
Exactly. This is going to be way too big of a number, and the 3 is going to be too small to possibly give us the negative 15, right?
Yeah.
Okay, so what that means is that this is one of those not factorable situations. This one is not factorable. So remember I said that not all quadratic trinomials are factorable. This is one of those situations. If you just can't come up with two numbers that multiply to give you the number that you need and add to give you the number that you need, then that situation is just not factorable. That's it. There's nothing more you can do about it. All right, this one. Okay, so the thing about this problem that I wanted you guys to see is that sometimes you can have a GCF just to start with. So all three of these, isn't there a number that I can divide out from all of these?
Um, yeah.
Okay, which is what?
Like a 2, you
Yes, exactly. So the GCF, there is a GCF here already, and we can factor that out. So that's the first step you want to do, is factor out the GCF. So if we did factor out a GCF, then what would we have? That would just be like a 2, and then what will be the rest of it in the parentheses?
Okay, then you would have like a 2x squared
Uh-huh.
and then a minus 1x
Yes.
and then a minus um 21.
Perfect. Okay, so now that we have these, right, this is the thing that we want to use as our quadratic trinomial. So we're going to try that on the side. We need two numbers, once again, that multiply to give us what and add to give us what.
Uh, Multiply to give us, that's going to be 2 times negative 21. So that's negative 42.
Awesome.
And then they have to add up to give you a -1.
Okay, awesome. So, can we think of these two numbers? What are two numbers that multiply to give you -42?
Um, well, there's like the 2 and the 21.
Yes, but that's definitely not going to give us a -1. Yeah?
Yeah. We could do a 7 and a 6.
Yes, perfect. Okay, 7 and 6. They will multiply to give you a 42. Now we just need to make the signs work out. So what do you think? How do we get a -1 for when we add those?
You would have to use a -7 and a +6.
Perfect. And then does that work out over here as well?
Yes.
Okay, good. So now we have our two factors, which means we can just set up the next part of the problem. We'll leave this 2 out here, and then, it just kind of tags along with the rest of the problem. So over here, if we're going to make this 2x squared, and then we split this up still, just like before. So this is going to be -21. In between, we can write the -7x plus 6x, and then now we can group like before and take out the GCF. So let's just go ahead and finish this problem. Go for it, calculator. What's the GCF for the first part?
Um, well, that's just going to be like an x.
Perfect. And then inside the parentheses, what will we have?
You're going to have a 2x and a -7.
Awesome. And the next part, what can I take out from both of those?
Um, 3,
Yes, you can take out a 3. What sign?
a positive. You just use the same positive sign from here.
Good. And then what's going to be in the parentheses then?
Then you will have 2x -7.
Yes, that's correct. Very nicely done. And tell me what these factors are now.
Okay, so you're going to have a 2x -7,
Uh-huh.
and then the other one will be x plus 3, and then that's it.
Okay, good. But what's not totally it, because we have this 2, so we want to keep this 2 tagging along. So there is actually a 2 in the front as well. So this is the final answer. Cool?
Yes.
Okay, awesome. One thing I want to say here is that all of these are expressions. So for all of these problems, we are only using quadratic trinomial expressions, and that's all that we're factoring. I'm not actually showing you how to solve the equation because there is no equation. So this video is really just about the factoring process. Okay, for this problem, the thing that I wanted you to see, actually, let me see if you can tell what it is. Can you see what's different about this problem?
Uh, oh, yeah. There's like a y. There's y's.
Yes, exactly. So this one has x squared, xy, and then y squared.
Oh, so how do you factor this one then?
Well, actually, this is done the exact same way. So nothing about it is different, but I do want to tell you what you have to look for in order to do this. So the pattern has to be like this, where see this first term is with the x squared. Think like this. Like I'm a really visual person, so I'm going to try and explain it in this visual kind of model. So this is x squared right here, and then this one is x to the 1. And then this one, there is no x. So it's like just, x is 0 power or something like that. And then the other one for y squared is like if I wanted to have a representation for y squared, maybe I can make the really long line as well. And then over here is just a 1y. And so if you have this sort of a situation where you're seeing that it goes like this is what's happening with the exponents and with the degrees of the variables, then that means you are good to go. You can factor it just like normal. So we have y squared, then y, and then the x squared and x. And so it is actually kind of like this diagram that I showed you. If you're watching this and you don't really understand this, then don't worry about it. But personally, I just really like understanding things visually. So that's kind of what that's about. All right, but we're going to go ahead and try this problem like normal. So let's go ahead and do the setup. What is that going to be? Two numbers that multiply to give us and add to give us what?
You're going to have two numbers that multiply to give you 6,
Okay,
and they have to add to give you 7.
perfect. And so do you know what those two numbers are going to be?
Um, yeah. I think we can just do 6 times 1, right?
Yes, a 6 times 1 will give us 6, and 6 plus 1, whoops, that's supposed to be a plus sign right there, will give us the 7. So this is perfect. And then from here, you would just write it out just like before. This time you're going to say 3x squared. And then the middle one is going to be plus 6xy plus 1xy, and then plus 2y squared. Yeah?
Okay.
Awesome. So then from here, we're just going to leave it blank for you guys to finish the problem out from this step. And then let's take a look at the next one. Okay, so what's different about this one?
This one has the 4th power.
Yes, that is one of the big differences. And then there's one other difference here.
The negative in the front.
Yes, exactly. Okay, so this problem is also done exactly like before. Nothing about it has changed, other than the fact that these look, a little bit more intimidating here. So you would find two numbers that multiply to give you a negative 15, because you have to multiply negative 1 times positive 15. So that's going to have to be a negative 15. And then the same two numbers have to add to give us a 2. And this is an adding symbol. I don't know why I'm putting multiplications in there. Okay, there we go. So you would have to come up with those two numbers. And then after that, then you would just go ahead and separate these out just like before. So you'd have negative x to the fourth. And then the middle one is going to be whatever your two numbers are, which we're going to leave for you guys to figure out. But once you have those two numbers, let's say they are 3 and 1, let's say. So if they were 3 and 1, which would not make sense here, you would just have a plus 3x squared and then plus 1x squared. So the main idea is just to remember that these are going to be the same as that middle term, and then the rest of the problem is the same. All right, so we're going to leave that alone, and then let's look at this very last problem. This one is x squared minus 9x plus 8. So this one is actually the easiest problem. And the reason I left this for last is because I think this is the thing that a lot of students learn, and then they try using the same method for these type of problems, and that's why they get them wrong and think that they don't know how to factor anymore. So let's go ahead and go through it. I'll show you what I mean. So two numbers that multiply to give us what and add to give us what?
Multiply to give us 8,
Yes,
and then add to give us negative 9.
yes. Awesome. So what's the A here, by the way?
Um, it's just a 1, right?
Yes, exactly. It's an invisible 1 right there. Okay, so then two numbers. What are the two numbers going to be? What do you think?
Um, so could we use 8 and 1?
Yes, and the signs?
They would both have to be negative.
Yes, that's what's going to give us the negative 9. Perfect. Okay, so the thing about these problems is that as soon as you've figured out what your two numbers are over here, then you can pretty much put it into the format right away, into the factored form. You're just going to do the x minus 8, and then the other one becomes x minus 1. So those came from, like, this is the 8 right here, and then this is the minus 1. And the reason I taught it to you the other way, where we did all the steps in between here, we didn't like go right from here to here, right? Is because that's what you have to do when there is a number other than 1 in the front, when that leading coefficient is something else. See, all of these, they all have numbers right there in the front. And that, whenever you see the number in the front of these problems, that's when you have to do this whole long process. But if you don't have those numbers in the front, then you can actually just skip right to the answer after you've figured that out. And so, yeah, I think the way that they teach it in school a lot of times is first they'll teach you the method of what to do when it's just the x squared, this kind of thing. And then they teach you this one. But sometimes students don't realize that this is a whole separate way of doing it and that there's steps in between. So that's why I like to teach it the other way around, where I'm teaching you how to factor with the more complicated steps and then I show you the easy one because then that way, if you have learned this one, you're never going to get the problems incorrect. And even if you use all those steps for this problem, you'll still end up with the same answer. I hope you guys found that helpful. Don't forget to try out the problems in the PDF and let us know in the comments how you did. And if you have any requests for any specific topics that you want us to cover, let us know that too. All right, thanks. Bye.